All right, let's dive in. Today, we're looking at something pretty cool. Modular building with aluminum framing.
Oh, interesting.
Yeah, and specifically, we're focusing on M.H.S. Building Systems.
Okay.
They've got this innovative approach to prefab modules.
Hmm.
You know, it might surprise you to hear that aluminum is becoming uh, a real player in construction,
Oh, yeah, I can see that.
an industry that's, usually all about steel and concrete.
Right, right. It's really interesting to see that shift happening, and I think it makes a lot of sense.
Yeah.
With the growing focus on sustainable building, aluminum is proving to be a surprisingly versatile material.
And sustainable, yeah.
Definitely.
So we've got this document all about MHS framed prefab modules,
Okay.
and it's packed with details.
Hmm.
But before we really jump in, can you maybe give us some context?
Sure.
Like, what exactly is modular construction?
So modular construction is basically building structures off-site in a factory setting,
Okay.
producing like these ready-to-assemble units.
Like modules?
Yeah, modules. And then those are transported to the construction site.
Makes sense.
And this approach offers a ton of advantages, actually.
Yeah, I bet.
Shorter construction times, less waste, improved quality control, smaller environmental footprint compared to like traditional building.
Yeah, that's huge, especially nowadays.
Exactly, with sustainability becoming so important. It's not really surprising that modular construction is gaining traction.
Makes sense, yeah. Okay, so let's maybe zoom in on MHS and their aluminum-based system.
Okay.
What makes their approach unique?
Well, a few things, really.
Okay.
This document mentions framing envelopes.
Yeah, what are those exactly?
So imagine a giant Lego set
Ah, okay.
made of aluminum posts and beams.
Mm-hmm.
They form the basic outline of rooms, maybe even entire floors.
Wow.
And these framing envelopes are delivered on-site with the roof and floor already in place.
So they're pretty much ready to go.
Yeah,
Mhm.
and they often use what are called structural insulated panels, or SAPs for short.
SIPs.
Yeah,
Okay, hold on. Can you unpack that a bit?
sure.
What are SIPs and why are they important here?
So SIPs are these high-performance building panels.
Okay.
They're made up of a core of rigid insulation sandwiched between two structural facings,
Mm-hmm.
usually oriented strand board.
So like OSB.
Yeah, exactly.
Mhm.
And they're great for insulation, they're strong, and they're really airtight.
Sounds pretty efficient.
Yeah, so they're a popular choice for energy efficient and sustainable construction,
Makes sense.
which is what MHS is all about.
Right, right. So these modules basically arrive on site like a blank canvas, ready for walls, windows, all the finishing touches.
Pretty much, yeah. And one of the biggest advantages is the versatility.
Oh, okay.
These modules come in standard sizes.
Like what?
Think, 8 by 12 feet, 8 by 16, and so on. And they can be combined in all sorts of configurations.
Oh, interesting. So you could build like anything from a tiny house to a huge apartment complex.
Exactly. From a small backyard studio to a sprawling multi-story building, yeah.
That's wild. So we've got speed, efficiency, versatility. But let's talk about the elephant in the room.
Okay.
Is aluminum really strong enough to be the backbone of a whole building?
It's a good question, and I think there's a bit of a misconception there.
Yeah. I mean, when I think sturdy structure, I usually picture steel or concrete.
Right, but while aluminum might not be the first thing that comes to mind, it actually has this incredible strength-to-weight ratio, meaning it's super strong for how light it is.
Okay.
And that's where the concept of the resistance skeleton comes in.
Okay, I gotta admit, resistance skeleton sounds a little intimidating.
It's not that bad, really.
Okay, good. Break it down for us. What is it, and how do these MHS modules, how do they enhance it?
So the resistance skeleton is basically the structural framework that gives any building its strength, its stability.
Okay.
It's what resists the different forces that act on the structure, like gravity, wind, even seismic activity.
Right, right.
Think of it like the human skeleton. Our bones support us so we can stand up and move, and buildings need a similar framework to resist collapsing.
So it's like the building's bones.
Exactly. And MHS modules are actually engineered to enhance this resistance skeleton. They distribute forces evenly throughout the structure.
Oh, I see. So instead of just relying on the strength of the material itself, they're designed with like specific engineering in mind.
That's right.
That's pretty cool. And I imagine that pre-engineering leads to better quality control too, compared to traditional construction where there might be more room for, mistakes.
Absolutely. By manufacturing these modules in a controlled factory setting, MHS ensures consistency and precision, Every module is built to the same standards.
Makes sense. And speaking of on-site, how do these modules actually get integrated into a real building project? It must take a lot of coordination between MHS, architects, and contractors. They can't just drop off a pile of modules and expect everyone to figure it out, right?
You're right, it's a very collaborative system. Their team works really closely with architects during the design phase
Okay.
to make sure the modules fit the needs of the project. Then, they give really detailed plans and instructions to the contractors who handle the on-site assembly and the finishing.
So it's like a well-coordinated dance between MHS and the local construction teams. That makes me wonder, are there any limits to what you can build with this system? Can it adapt to different architectural styles, building codes, that kind of thing?
That's actually one of the most remarkable things about the MHS system, how adaptable it is. While the modules themselves provide that structural framework, they're basically a blank slate when it comes to the final design. Architects can incorporate a whole range of exterior finishes, brick, wood siding, whatever they want, to get that desired aesthetic.
So you're not limited to just one look.
Not at all. And because the modules are engineered to meet or exceed building codes, they can be adapted to pretty much any location and climate.
Wow, that's really impressive. They've managed to create a system that's both incredibly innovative and super flexible.
Yeah, it's pretty remarkable.
But we haven't even touched on the sustainability aspect yet.
Right.
We know aluminum is recyclable, but what are the bigger environmental benefits of building with the system?
That's where it gets really interesting. Remember those SIP panels we talked about?
Yeah.
They play a big part in the overall sustainability of these modules.
Yeah.
SIPs provide exceptional insulation, so you need less energy to heat and cool the building.
Right, that makes sense. Less energy used, less impact on the environment.
Exactly. And they create this tight building envelope, minimizing air leakage, which further enhances the energy efficiency.
Okay, so we're talking about buildings that are not only faster and easier to construct, but also much more energy efficient to operate.
Yeah, it's a win-win for the building owner and for the environment.
Totally. But what about the environmental impact of, actually producing these modules in the first place?
That's a really important consideration.
Yeah.
And MHS has actually taken some big steps to minimize their footprint.
Okay, good.
Like you mentioned, aluminum is highly recyclable.
Right.
Something like 75% of all the aluminum ever produced is still in use today.
Wow, that's amazing.
So building with aluminum taps into this closed-loop system, significantly reduces the need for new materials.
That's huge.
And the controlled factory environment allows for much more efficient use of materials
Okay.
and minimizes waste during production.
So from the materials to the manufacturing process to the energy efficiency of the building itself,
Yeah.
it seems like MHS is really thinking about all aspects of sustainability.
They really are.
Yeah.
They're committed to making this a genuinely environmentally responsible approach to construction.
It's impressive.
And their efforts have gotten some recognition, too. MHS actually won the A Design Award,
Oh, wow.
specifically for their innovation and sustainability.
That's fantastic. It really seems like they're leading a revolution in the way we build.
I think so, yeah.
But before we get too carried away, let's take a closer look at the practical side of things.
Okay.
In the next part of our deep dive, we'll explore how this system could impact construction timelines and costs.
Sounds good.
And we'll also talk about the broader implications of modular construction for housing, labor, the future of the industry as a whole.
I'm looking forward to that.
Stay tuned. We're just getting started.
All right. So, before we get into that bigger picture stuff,
Yeah.
let's talk about the speed and efficiency of this whole system.
Okay, yeah.
You were really interested in that.
Oh, absolutely, yeah. This document, it throws out some pretty wild numbers.
Does it?
Yeah, they claim these modules can cut down construction time by up to 60%.
It's pretty remarkable, yeah.
Is that even possible?
It is, and the document kind of explains how they do it.
Okay.
First of all, factory production, well, it totally eliminates weather delays,
Right.
which can be a huge factor in traditional construction.
Oh, yeah, for sure.
Then there's the streamlined on-site assembly.
Right.
The modules arrive mostly prefabricated,
Yeah.
so you're not dealing with the same level of complexity as a traditional build.
Okay, so it's more than just snapping together pre-made pieces. There's a whole system designed for efficiency, basically.
Exactly.
Yeah.
Efficiency at every single stage.
Gotcha.
And it's not just limited to time either.
Oh, okay.
The document also talks about the cost savings with this approach.
Yeah, I was going to say, 60% faster build time, that's going to mean some serious savings on labor costs, right?
You're absolutely right. Fewer man-hours on site, Lower labor costs,
Yeah.
plus less need for heavy machinery, reduced material waste, thanks to that controlled factory environment.
Right,
It
right.
all kind of adds up. Those savings cascade through the whole project.
Makes you wonder, could this be like a key to tackling those rising construction costs?
Yeah.
Making housing more affordable.
It's a question a lot of people are asking. It's not a magic solution, but the potential is definitely there.
Yeah.
Faster, more efficient construction could lead to lower development costs,
Right.
which theoretically could mean more affordable housing, especially important in cities where housing shortages are a big problem.
For sure, for sure. But let's not forget the environmental impact, right?
Yeah.
We talked about aluminum being recyclable, but are there other eco-friendly aspects to this system beyond the material itself, I mean?
Absolutely.
Right.
Modular construction, just by its nature, is pretty sustainable.
Okay.
Factory production minimizes waste,
Right.
and using SIPs,
Hmm.
like in the MHS system, contributes a lot to energy efficiency.
I'm actually curious, how do SIPs compare to like traditional insulation? Performance-wise, environmental impact, all that.
Well, SIPs offer much better insulation than, say, fiberglass or cellulose.
Yeah. Okay.
So you need less energy to heat and cool the building,
Right, right.
which obviously reduces its carbon footprint over time.
Yeah.
And generally, producing SEPs has a lower environmental impact than some traditional insulation materials.
So from the sourcing to the energy use, it seems like this MHS system is like checking all the boxes for sustainability.
They're doing a lot of things right.
Yeah.
Yeah. And they're not stopping there.
Oh, really?
The document highlights their research into even more sustainable materials and processes,
Oh, cool.
like bio-based insulation, ways to reduce waste even further during production.
That's great to hear. A company that's not settling and, really pushing the boundaries of sustainable building makes you think, what other industries could use this kind of forward-thinking approach?
It's true, If they can revolutionize construction with aluminum and modular design,
Yeah.
who knows what else is possible?
Right. It's like, what's next?
That's the beauty of innovation. It sparks these new ideas,
Yeah.
pushes the boundaries of what we think we can achieve.
Imagine the possibilities.
I know, right? Think about disaster relief,
Oh, yeah.
where you need to get shelters up quickly, or even like space exploration.
Whoa, okay.
Lightweight modular structures for habitats on other planets.
That's pretty wild.
It is, isn't it? Science fiction becoming reality.
Yeah. But let's come back down to earth for a second.
Okay.
All this innovation is amazing, but how practical is it for, the average person?
Right.
Is this technology just for big developers or people with tons of money?
It's a good question. And the document doesn't get into specific pricing,
Okay.
but it does keep emphasizing the cost effectiveness of the MHS system over time.
So you're saying like maybe the initial investment is higher,
Potentially, yeah.
but the long-term savings like on energy and maintenance could make up for it.
Exactly. And remember those time savings we talked about?
Yeah.
Shorter construction means less interest on loans.
Oh, right.
And if it's a business, you can start making money sooner.
Yeah, that makes sense.
Those factors can make a big difference in affordability.
So it seems like this technology could benefit all kinds of projects, from individual homes to those, massive developments.
I think so.
But it also brings up questions about the future of construction itself, right?
That's right.
Like if modular becomes the norm, what happens to traditional construction jobs?
Right.
What skills will people need?
It's a really important point. The shift towards modular construction could create a demand for different skills.
Okay.
We might see more need for factory workers, skilled in manufacturing and assembly,
Right.
while on-site roles might become more specialized.
Like focused on specific tasks.
Exactly. Things like integration and finishing.
It sounds like we need to be ready for a pretty big shift in the construction industry.
Yeah, I think so. It's not just about new materials and tech.
Right.
It's about making sure the workforce can adapt and thrive in this new era.
It's an opportunity though, right?
Oh, absolutely.
Mm.
To create new jobs, elevate the industry as a whole.
Well, we've covered a lot. Aluminum, SIPs, cost savings, the workforce, all of it.
We have, yeah. That's a lot to take in.
But there's one crucial thing we haven't really gotten into yet.
And what's that?
The design process.
Oh, right.
How are these modules actually integrated into real architectural projects?
Yeah, that's the key piece, isn't it? It's one thing to understand the tech,
Right.
but it's another to see how it all comes together in an actual building.
Exactly. So in the last part of our deep dive, we're going to shift gears.
Okay.
Focus on that collaborative design process.
All right.
explore how architects and MHS work together to bring these innovative structures to life.
Looking forward to it.
Stay tuned. Welcome back to the deep dive. We've been digging into the tech side of MHS's modular system, all that cool stuff. But let's get down to brass tacks. How do these aluminum modules actually get used in real projects?
It all comes down to teamwork, really.
Okay.
MHS's design team, the architects, the contractors, they all work together really closely.
From what I've seen, it seems like MHS isn't just selling those prefab parts. It's more like they're offering a whole design and support package, the whole shebang.
Yeah, that's a good way to put it. They work hand in hand with architects right from the beginning throughout the entire design process,
Makes sense.
making sure those modules fit seamlessly into the overall vision for the building.
So it's not like a one-size-fits-all kind of deal.
No, not at all.
Architects still have the freedom to design something unique.
Absolutely. The modules are more like a flexible framework, a starting point.
Okay.
The architect's vision, the specific needs of the project, that's what really shapes the final design.
So they can tweak things, make adjustments.
Oh yeah, for sure. MHS can modify those standard modules to meet all sorts of different requirements,
Like what?
adjusting dimensions, adding custom openings, incorporating special features, you name it. They're pretty flexible.
That's pretty cool. I was a little worried, that modular construction might limit design choices.
I get that.
But it seems like MHS has found a way to to balance that standardization with the need for customization.
They have, and that's a big part of why they're so successful. They get that people want both, the efficiency of prefabrication, but also the ability to create something that's truly unique.
Yeah, totally. So once the design is all finalized, how does the on-site assembly actually happen?
Mm.
Is it as easy as just clicking those modules together like a giant Lego set?
Well, it's a little more complicated than that, but yeah, the pre-engineering definitely makes things a lot simpler.
Okay.
MHS provides these super detailed plans, instructions for the contractors, walks them through each step of putting it all together.
Got it.
And they've developed these specialized connection systems, make sure the modules are joined securely, accurately.
So it's still, you need specialized knowledge.
Right.
But it sounds way more streamlined than traditional construction. Less room for messing things up.
Definitely. And all that efficiency, it translates to savings too. Less labor on site, faster construction times. It all adds up.
We've been talking a lot about the financial and environmental benefits, but what about the people who are actually going to live or work in these buildings?
Yeah.
Is there anything different about designing the interior or how it all functions?
That's the great thing about the MHS system.
Yeah.
It really doesn't dictate the interior design at all. Once the modules are all assembled, finishing the interior is pretty much the same as any traditional building.
Okay, cool. So you can have exposed brick in a loft or a fireplace in a cabin, all within this modular structure.
Exactly, yeah. And because the modules are so energy efficient, you can often achieve a higher level of comfort while using less energy.
We keep coming back to those SIP panels, huh?
They really are a key part of the system. They provide that great insulation, and they also create that tight building envelope we talked about, less drafts, fewer temperature swings.
So it sounds like these buildings aren't just sustainable, they're also super comfy to live and work in.
That's the goal, right, to create spaces that are functional and beautiful while also being mindful of their impact.
Speaking of impact, we've talked about those bigger implications for housing affordability and the workforce.
Right.
But could this technology be used to tackle other challenges too, like disaster relief or maybe even homelessness?
Now that's where it gets really interesting, I think. The speed, efficiency, and adaptability of modular construction. It makes it perfect for emergency situations.
Yeah, I see that.
Imagine being able to get high-quality shelters to a disaster zone in just a few days,
Wow.
providing safe, comfortable housing for those who need it most.
That could be a game changer for sure.
Yeah.
What about using it to build more, I don't know, sustainable and affordable housing for people experiencing homelessness?
Look, a great idea. The cost-effectiveness, the speed of construction, it can make it much more feasible to build those kinds of supportive housing units, address a real critical need in so many communities.
It's pretty inspiring to think about how this technology could be used to make a difference in the world.
It all comes down to, thinking outside the box and being open to new ways of doing things.
Well, I've got to say, this deep dive has been eye-opening. We've covered so much ground, from aluminum framing to sustainability, cost savings, societal impact, you name it.
It has been a fascinating journey, that's for sure.
I encourage everyone listening to, do a little digging, learn more about MHS and what's happening in the world of construction. Things are changing fast, and it's exciting to be a part of it.
Who knows what the future holds, right? The possibilities seem endless at this point.
Thanks for joining us on this deep dive. We'll catch you next time.